Hi everybody. So this is the second video in my series, The Locus of Complex Numbers. So in my previous video, we looked at the magnitude of a complex number, let's say z, being equal to the magnitude of the complex number in x plus iy form. And to work out the magnitude of this in the Cartesian form, we can Pythagorize the x and the y. So the magnitude of z will be equal to the square root of x squared plus y squared. So if you're not sure how to do this, you should check out my previous video on this series. Okay, so for example A, we're going to find the Cartesian equation of this equation, and then we're going to sketch the locus from that. So for question A, if we replace this z with the x plus iy form, then we've got the magnitude of x plus iy minus 3 will equal 2. And now we've got a collection of real parts, the x and the negative 3, and the imaginary parts, y. So if we group these together, we've got the magnitude of x minus 3, which are the real parts, so I'll put this in brackets, plus the imaginary parts, iy. And again, this equals 2. And then from this form, we can Pythagorize this using this property. So the magnitude will be the square root of the real part, x minus 3 all squared, plus the square of the imaginary part, and this will equal 2. Now we can cancel out this square root by taking the square of both sides. So we've got x minus 3 squared plus the y squared will equal 2 squared, which is 4. And this is the equation of a circle, where you've got the center of 3 and 0. The radius will be the square root of a 4, so 2. Now we can sketch this circle. So we'll have the center of 3, a radius of 2, and this represents the locus of z minus 3 equals 2. Okay? So if we look at question B, again, we'll replace this z with x plus iy. So we'll have the magnitude of x plus iy minus 2 plus 3i. And this has a magnitude of 4. So again, if we collect the real parts, we'll have a magnitude of x minus 2. I'll put this in brackets, plus I multiplied by the y plus 3. And this will equal 4. Now we can Pythagorize this to find the magnitude. So we'll take the square root. We'll have the real part x minus 2 squared plus the imaginary part y plus 3 squared. And this will equal 4. So now we can cancel out the square root by squaring both sides. So we've got x minus 2 squared plus y plus 3 squared equals 4 squared, 16. So we can see in this circle, we'll have a center at 2 and negative 3, and the radius will be equal to the square root of 16, 4. If I just make some space so I can sketch the diagram, the circumference of this circle represents all the points that satisfy the magnitude of z minus 2 plus 3i being equal to 4. Okay?